What you need to apply is the following. Okay, I give you guys this holy grail of ML projects. Okay, just think of it as a blueprint. Okay, think of it as a checklist. Okay, so there are three different stages. Okay, three stages of this blueprint. Three stages. Okay, we have the preliminary, we have the essential, and we have the advanced. Okay, so for the preliminary, right? I already got a checklist for you guys at the end. You guys just need to follow through. So we are going to be a little bit more practical now, right? Okay, so first of all, obviously we're gonna formulate a problem and find data that is related to our problem. Okay, find data. Okay, and we're gonna decide on, obviously when we are formulating the problem, right? We're gonna decide on what domain it's gonna be. Is it gonna be a time series? Is it gonna be a NLP? Is it gonna be computer vision, or is it gonna be a no domain? Right, like Titanic, right? Tabular. Okay, maybe tabular is considered a domain now. Yeah. Okay, maybe I just write it down. If not, I say no domain, like real weird. Tabular, tabular. Okay, tabular is a domain now. Okay. Okay, then you're gonna ask questions like, what problem do I want to solve? Is it a regression problem or classification problem or recommendation problem or whatever? And the quality of it, what kind of effort I want to do, man. So right now, you guys can all focus on the schoolwork quality or pet projects quality or educational quality. Okay. And then, does your data set already exist? You need to ask questions like, do you need to script the data yourself? Do you need to manually label data yourself? You need to ask all these sort of questions. Okay. And preferably do this with a team. Yeah. And then most important of all, you need to set up your shelf. Okay, you need to put a shelf in the library, man. So you need to set up your GitHub. You need to learn Git. Essential stage, right? These are the essential things you must do. Okay. First of all, obviously, okay. So now you came out with your problem. You've also found your data. You also manage your environment. You also created environment and manage your dependencies. You're ready to go. Okay, you're ready to start Jupyter Notebook and start working. Okay. However, we're gonna first do some things. Okay, we're gonna research. Okay, this is a very important stage. We're gonna research similar projects and read tutorials, as many as we can. Okay, and then if best, we can copy the code. Okay, and then we will tweak a little bit of that code. Okay, to make it ours. Okay, and then the second step is, once we got the data, we'll open a Jupyter Notebook session, right? And then we will conduct something called EDA, which is exploratory data analysis. Okay, and then basically what we want to do with EDA is we want to understand the data. Okay, like for example, the housing prices, like what are the average housing prices, stuff like that. What is the median? These are all very, very important. Okay, you got to get a good sense of the data to build good models. Okay, it's very hard to explain the whole intuition behind it. You got to train one model before you can truly understand the value of exploratory data analysis. Okay, so once you're done with your analysis, you can now train your baseline model. Okay, what the hell is a baseline model, you may think? Okay, so in machine learning projects, right, anywhere in the world, you're doing school projects or you're working for a company or you're working on pet projects, right, it is universally understood that you have to train a baseline model. A baseline model also means the first basic model. The first basic model. You got to train a very, very basic model so you got something to compare to, right? So if you're working on a regression problem, you can start with linear regression, without regularization, and then you can classification problem. You can start with decision trees or logistic regression. So something very, very basic, right? So you have some score to compare to. Okay, so and then where is my wait? So I'll just show you guys the example of the report that we saw just now, right? You can see this report. These are the different algorithms I tried, right? Okay, and then this is the score. This is my baseline model. Logistic regression is my baseline model. So whatever new models that I try to train, my objective is to beat this model. For example, I will want the balance accuracy to win this number. Okay, as long as I win this number, right, I'm good. okay, then I will keep the model. Okay, I will improve the model. If my second model is poorer than this, then I can forget about second model. I just pick another model. I can pick another algorithm. Okay, so this is why we have a baseline algorithm. Sorry, baseline model. Okay. I can see the next step is to train a better model that beats your baseline model in performance. This is universal. You cannot skip this. Very universal. Okay. For a regression problem, for example, you can start with more advanced ones with regularization, like Reach or Lasso or ElasticNet, which combines the two. And then we have classification problem. We can use like even more advanced tree-based algorithms like XGBoost, boosting algorithms, XGBoost and GBM. Okay, and then once you got your good models and you beat your baseline model performance, right? And then you can, obviously this is not chronological order, right? You're going to evaluate your model anyway. Okay, you're going to evaluate your model. You're going to write some analysis, and then you're going to write a kick-ass README. Okay, what is a README? What the hell is a README? README is, like I said, if a repository is a book, right? Your README is like the book cover. It's what people will be first greeted with. If your repository is a house, right? The README will be the design of the exterior of the house. So you want the house to be, the exterior of the house to be super beautiful. Okay, that's why you need a super duper kick-ass README, right? To keep people, let people stay in your repository and read your analysis. Okay, and let them come to conclusions that you are going to be useful. Okay, so some sections you include README, obviously an introduction and setup. Setup means the how can they run your code. Basically, the section that describes to them how can your reader run your code. Analysis, we already saw some examples just now. Further work, what is the checklist? Is there more things to be done? And we have resources. Who are the people you want to give credit to? Okay, so these are the essential steps you need to do. Okay, period. Really, if you are working on a machine learning project, okay, machine learning, okay. So going to the last one, it will be advanced. Okay, if you are, let's say you are done with preliminary and it's essential, and you're just looking for more. Okay, you already have a kick-ass resume, kick-ass README, and you just want to impress people more. You just want to learn more stuff. Okay, then you can read into how to write unit tests. Okay, for those who don't study computer science, it's okay. I didn't know what are unit tests also, but unit test is like a must-have for any piece of software, any piece of web application, any piece of function that you want to deploy on any piece of application. I think I repeated that. Yeah. So basically, a unit test is essentially a test to ensure the correctness of the functions you write. Okay, so for example, I'll show you one problem that I have. So one problem that I had that I tried to solve is basically I'm trying to build an algorithm, okay, that to solve this problem. How to it's basically a minimum spanning tree problem. Okay, I just cannot explain that problem now, but I'll show you for the sake of it what is a unit test. Okay, so I have some sort of a function in my src folder. Okay, this is my function. Let's go to this Python file. Okay, and I have some, you can see I have several functions. Okay, these are all functions. DEF are functions. Okay, so by right, you have to write unit tests for your functions. So you got to test that your functions, given a variety of inputs, right, really do give you an expected output. Yeah, really do give you an expected output. So the unit test looks something like this. So let me try to go to the repository. Okay. So I'm in the tree spanning rods repository, which is this. Okay, you can see you can see these are my folders I have, okay? And then you can see what happens if I run a unit test. Okay, let me just, okay, so this is the unit test file. Okay, I'll show you a unit test file I have. It's basically another Python file. The unit test is basically another Python file. I'm sorry if I'm not explaining myself properly, but I can only show you guys. Okay, so this is the function that I have in the just on the Python file. Okay, you can see I made another function. Okay, so this function, there's this test underscore in front of this function name. Okay, what this function do is basically test this function, test this function. This function is to test this function, given this variety of inputs. Okay, and this is a skill you need to have. Okay, if you go to internships or you go and work on a job, you definitely have to write unit test. So if I run the unit test, right, you can see test session starts. Okay, and then start collecting my scripts and tell me what Python version I'm running and stuff. So you can see, give you a moment. I'm not sure why is it taking so long? Yeah, okay, so you can see it has like 18 items to test. Okay, and then it tests everything, right? If it passes, right, if it gives you the expected output, right, you will write a pass here, right? And then it will tell you everything passed in 25 seconds, stuff like that. Windows are neat or nice terminal because you have too many. Okay, I'll answer the questions later, okay? And yeah, so this is basically unit test. You have to test the correctness of your function. You can't just write a function and expect it to be correct. Okay, you can, I mean, if you are a student, but as you grow, you definitely need to write unit tests. So back to this, right? Advanced blueprint, okay? And then we're gonna learn how to use local Docker deploy, okay? What the hell is we're gonna learn how to local deploy your model or your algorithm as a microservice. By the way, this algorithm I state here is not referring to ML algorithms, okay? ML algorithms are not, you need to deploy them because they're all code. Okay, this algorithm is basically a series of steps. It can be meant to solve anything. You can build your own algorithm. Okay, and a microservice here is basically just now you saw an example, right, in the video that the guy like the computer vision machine learning project that input an image and then outputs the recipe, right? The app, right, you can see he did it in his mobile, right? And the mobile, right, is a microservice. Okay, so the model is deployed in the mobile app. Okay, so when I say local deploy here, right, local deploy means deploy in your computer, right? Deploy in your computer. So you don't have to deploy to the Google Cloud platform or the Microsoft Azure for millions of people to use. You don't have to, but you got to at least deploy it in your computer. Okay, it's very, very contradictory when I say it in your computer because the model itself is already in your computer, right? But it's not as simple as that. You gotta deploy it so that you can access it via a protocol like RESTful API. Okay, this is computer science related stuff, really. Okay, if you work as a data scientist, right, machine learning engineer, data engineer, right, you definitely have to know this one. You cannot skip this one. Okay, you won't be analyzing charts or building models all your life as a data scientist or machine learning engineer or whatever engineer. You have to learn how to make APIs, deploy your models. Okay, unless you're a business analyst or data analyst. Okay, and then several more advanced checklists is you have to adhere to naming conventions. Okay, so for example, repository, right? Repositories names, right? You have to be something like this. Okay, it have to be lowercase and separated by a dash instead of an underscore. So for Jupyter Notebooks, everything lowercase and separated by underscore, and maybe at the end you can add the date.